Welcome to second video on trigonometry. There are 10 problems on trigonometry. These are the first 6 problems and these are the last 4 problems. This is the content. First problem is prove that 1 minus tan theta by 1 minus cot theta whole square equals to 1 plus tan square theta by 1 plus cot square theta. Now the LHS is 1 minus tan theta by 1 minus cot theta whole square, that is 1 minus tan theta whole square by 1 minus cot theta whole square. Now convert the expression into a function of cot theta. We know tan theta equals to 1 by cot theta. Then put tan theta equals to 1 by cot theta and we get 1 minus 1 by cot theta whole square by 1 minus cot theta whole square, which is equals to cot theta minus 1 whole square by cot square theta by 1 minus cot theta whole square. Now 1 minus which is equals to 1 minus cot theta whole square by cot square theta by 1 minus cot theta whole square. Now 1 minus cot theta is cancelled and we get 1 by cot square theta. We know 1 by cot theta equals to tan theta, then this expression is equals to tan square theta. We know tan theta equals to sin theta by cos theta. Then this expression is equals to sin square theta by cos square theta. We know sin theta equals to 1 by cosec theta and cos theta is equals to 1 by sec theta. Now this expression is equals to 1 by cosec square theta by 1 by sec square theta, which is equals to cosec square theta by sec square theta by cosec square theta. Now we know sec square theta equals to 1 plus tan square theta and cosec square theta equals to 1 plus cot square theta. Now put the value of sec square theta and cosec square theta from those identity and we get 1 plus tan square theta by 1 plus cot square theta, which is the RHS. Hence proved. Is a sin x minus b cos x equals to c. Then so that a cos x plus b sin x equals to plus minus root over a square plus b square plus c square. Given that a sin x minus b cos x equals to c. Now square both sides and we get a sin x minus b cos x whole square equals to c square. Now express it in the form a square sin square x plus b square cos square x minus 2ab sin x into cos x equals to c square. We know sin square x plus cos square x equals to 1, then sin square x equals to 1 minus cos square x and cos square x equals to 1 minus sin square x. Now put the value of sin square x and cos square x from this identity. Sin square x plus cos square x equals to 1 and we get a square into 1 minus cos square x plus b square into 1 minus sin square x minus 2ab sin x into cos x equals to c square. Now which is equals to a square minus a square cos square x plus b square minus b square sin square x minus 2ab sin x cos x equals to c square. Now which is equals to minus a square cos square x minus b square sin square x minus 2ab sin x cos x equals to c square minus a square minus b square. Now take minus common and cancel, then we get a square cos square x plus b square sin square x plus 2ab sin x cos x equals to a square plus b square plus c square. Now a square cos square x plus b square sin square x plus 2ab sin x cos x is a cos x plus b sin x whole square. Then a cos x plus b sin x whole square equals to a square plus b square minus c square. Now from this we get a cos x plus b sin x equals to plus minus root over a square plus b square minus c square. After square root from both sides we get a cos x plus b sin x equals to plus minus root over a square plus b square minus c square. Hence proved. Then is this: show that 1 by cosec x minus cot x minus 1 by sin x equals to 1 by sin x minus 1 by cosec x minus cosec x plus cot x. This expression means 1 by cosec x minus cot x plus 1 by cosec x plus cot x equals to 2 by sin x. Now if we prove this expression, then also we prove this expression. Now let's take 1 by cosec x minus cot x plus 1 by cosec x plus cot x as LHS. Then LHS is equals to cosec x plus cot x plus cosec x minus cot x by cosec square x minus cot square x. Now plus cot x and minus cot x cancelled and we get the expression is equals to 2 cosec x by cosec square x minus cot square x. Now we know a identity: cosec square x equals to 1 plus cot square x. Then cosec square x minus cot square x equals to 1. Now put the value of cosec square x minus cot square x equals to 1. Then the expression is equals to 2 cosec x by 1, which is 2 cosec x. We know cosec x is equals to 1 by sin x. Then the expression is equals to 2 by sin x, which is the RHS of the expression of this expression. Then the expression is proved, which means the given expression is also proved. The next problem is find the minimum value of cos squared x plus sec squared x. Now we know cos squared x plus sec squared x equals to we know a square plus b square equals to a minus b whole square plus 2ab. Then cos square x plus sec square x equals to cos x minus sec x whole square plus 2 cos x into sec x. We know sec x is equals to 1 by cos x. Then 2 cos x into sec x is equals to 2 into cos x into 1 by cos x. Cos x and 1 by cos x cancelled and we get 2. Then this expression is equals to cos x minus sec x whole square plus 2. Now we know any square term is greater than equals to 0. Then cos x minus sec x whole square greater than equals to 0. Now cos x minus sec x whole square plus 2 always greater than equals to 2, because we add 2 in RHS in right side and left side. Then we know cos x minus sec x whole square plus 2 is equals to cos square x plus sec square x. Then put the value of cos x minus sec x whole square plus 2. We get cos square x plus sec square x greater than equals to 2. Then the minimum value of cos square x plus sec square x equals to 2. 2y cos theta equals to x sin theta and 2x sec theta minus y cosec theta equals to 3. Then prove that x square plus 4y square equals to 4. Now this is given 2y cos theta equals to x sin theta. Then cos theta by x equals to sin theta by 2y. Then we know if a by b equals to c by d, then a by b equals to c by d is equals to plus minus root over a square plus c square by root over b square plus d square. Then cos theta by x equals to sin theta by 2y is equals to plus minus root over cos square theta plus sin square theta by root over x square plus 4y square. We know the identity sin square theta plus cos square theta equals to 1. Then this expression is equals to plus minus root over plus minus 1 by x square plus 4y square. Now here we put cos square theta plus sin square theta equals to 1. Then from this expression we know cos theta by x equals to plus minus 1 by x square plus 4y square. Then cos theta equals to plus minus x by root over x square plus 4y square. And sin theta by 2y is equals to plus minus 1 by x square plus 4y square. Then sin theta is equals to plus minus 2y by root over x square plus 4y square. Now in the problem 2x sec theta minus y cosec theta equals to 3 is given. Then we know sec theta equals to 1 by cos theta and cosec theta is equals to 1 by sin theta. Then put the value of sec theta and cosec theta, we get 2x into 1 by cos theta minus y into 1 by sin theta equals to 3. Then 2x by cos x minus y by sin x equals to 3. Now put the value of cos x and sin x in this expression and we get 2x into plus minus root over x square plus 4y square by x minus y into plus minus root over x square plus 4y square by 2y is equals to 3. Now simplify this equation and we get plus minus 3 by 2 root over x square plus 4y square equals to 3. From both sides divide both sides by 3 and we get plus minus root over x square plus 4y square equals to 2. And now square both sides and we get x square plus 4y square equals to 4. Hence proved. The next problem is if in equals to cos to the power nx plus sin to the power nx, then show that 2i6 minus 3i4 plus 1 equals to 0. Now first find the value of i6. i6 equals to cos to the power 6x plus sin to the power 6x, which is equals to cos square x whole cube plus sin square x whole cube. Now we know a cube plus b cube equals to a plus b whole cube minus 3ab into a plus b. Then cos square x whole cube plus sin square x whole cube is equals to cos square x plus sin square x whole cube minus 3 cos square x sin square x into cos square x plus sin square x. Then put from the identity cos square x plus sin square x equals to 1, put the value of cos square x plus sin square x. We get 1 minus 3 sin square x into cos square x. Now find the value of I4. I4 is equals to cos to the power 4x plus sin to the power 4x equals to cos square x whole square plus sin square x whole square. Now use the formula a square plus b square equals to a plus b whole square minus 2ab. Then cos square x whole square plus sin square x whole square equals to cos square x plus sin square x whole square minus 2 cos square x into sin square x. Now here also put cos square x plus sin square x equals to 1 and we get 1 minus 2 sin square x into cos square x. Now LHS of this problem is 2i6 plus 3i4 plus 1, which is equals to, here we will first put the value of i6 and i4 and we get 2 into 1 minus 3 sin square x cos square x minus 3 into 1 minus 2 sin square x cos square x whole plus 1. Simplify this and we get 0, which is the RHS, hence proved. The next problem is if 1 plus sin square x equals to 3 sin x into cos x, then find the values of tan x. Here given 1 plus sin square x equals to 3 sin x into cos x. Now we know sin square x plus cos square x equals to 1. Then we write sin square x plus cos square x in the place of 1. Then sin square x plus cos square x plus sin square x equals to 3 sin x into cos x. Here we put sin square x plus cos square x in the place of 1, or 2 sin square x plus cos square x equals to 3 sin x into cos x. Now divide both sides by cos square x. Then we get 2 sin square x by cos square x plus cos x by cos x equals to 3 sin x by cos x, or 2 tan square x plus 1 equals to 3 tan x. We know tan x equals to sin x by cos x. Then we put tan x in the place of sin x by cos x and we get 2 tan square x plus 1 equals to 3 tan x, or 2 tan square x minus 3 tan x plus 1 equals to 0. Now factorize the expression 2 tan square x minus 3 tan x plus 1. We get tan x minus 1 into 2 tan x minus 1 equals to 0, or tan x equals to 1 or 1 or 1 by 2. Here if you want you can use Siddharacharya formula. Then x equals to 3 plus minus root over 9 minus 8 by 4, which is equals to tan x equals to, then tan x equals to 3 plus minus 1 by 2, or tan x equals to 1 or 1 by 2. In both the way we get the value of tan x equals to 1 or 1 by 2. Then the values of tan x is 1 and 1. The next problem is if sin x minus cos x equals to root 2 cos x, then show that sin x plus cos x equals to root 2 sin x, where 0 less than x less than pi by 2. In the question, this is given sin x minus cos x equals to root 2 cos x. Now square both the sides and we get sin x minus cos x whole square equals to 2 cos square x, or sin square x plus cos square x minus 2 sin x into cos x equals to 2 cos square x, or sin square x equals to cos square x plus 2 sin x into cos x. Now add sin square x and then subtract minus sin square x from right side. We get sin square x equals to cos square x plus 2 sin x into cos x plus sin square x whole minus sin square x. Here we first add sin square x, then subtract sin square x from right side. And we get sin square x equals to cos square x plus 2 sin x into cos x plus sin square x whole minus sin square x, or 2 sin square x equals to cos x plus sin x whole square. Now square root both the sides and we get cos x plus sin x equals to plus minus root over 2 sin x. Now when x is greater than 0 and less than pi by 2, then sin x is positive and cos x also positive, but minus root 2 sin x in when x is between 0 to pi by 2, then sin x is positive, then minus root 2 sin x is negative, then cos x plus sin x is not equals to minus root 2 sin x, because cos x plus sin x is positive but minus root 2 sin x is negative. Then when x is greater than 0 and less than pi by 2, then cos x plus sin x is equals to plus root 2 sin x. So cos x plus sin x equals to root 2 sin x when x is greater than 0 and less than pi by 2. Hence proved. The next problem is sin x plus cosec x equals to 2. Then prove that sin to the power 7x plus cosec to the power 7x equals to 2. Here sin x plus cosec x equals to 2 is given. Now convert cosec x into sin x. We know cosec x equals to 1 by sin x. Then sin x plus 1 by sin x equals to 2, or sin square x plus 1 equals to 2 sin x, or sin square x minus 2 sin x plus 1 equals to 0. That is sin x minus 1 whole square equals to 0, or sin x minus 1 equals to 0, or sin x equals to 1. Then cosec x equals to 1 by sin x equals to 1 by 1, which is 1. Then cosec x equals to 1. Now in the question, LHS equals to sin to the power 7x plus cosec to the power 7x. Then sin to the power 7x is 1 to the power 7 and cosec to the power 7x is 1 to the power 7. Then LHS equals to 1 to the power 7 plus 1 to the power 7, or 1 plus 1 equals to 2. That is the RHS, hence proved. Is if 1 plus cos A into 1 plus cos B into 1 plus cos C equals to 1 minus cos A into 1 minus cos B into 1 minus cos C, then prove that 1 plus cos A into 1 plus cos B into 1 plus cos C equals to 1 minus cos A into 1 minus cos B into 1 minus cos C equals to plus minus sin A into sin B into sin C. Now let 1 plus cos A into 1 plus cos B into 1 plus cos C equals to k. This is our equation number 1. And 1 minus cos A into 1 minus cos B into 1 minus cos C equals to k. This is our equation number 2. Then from equation 1 and 2 we get, now multiply the both equation, then we get, after multiplication we get 1 plus cos A into 1 plus cos B into 1 plus cos C whole into 1 minus cos A into 1 minus cos B into 1 minus cos C equals to k into k equals to k square. Then we know a minus b into a plus b equals to a square minus b square. Then 1 plus cos A into 1 minus cos A, we get 1 minus cos square A. Also, similarly, 1 plus cos b into 1 minus cos b is 1 minus cos square b, and 1 plus cos c into 1 minus cos c equals to 1 minus cos square c, or 1 minus cos square a into 1 minus cos square b into 1 minus cos square c equals to k square. We know the identity sin square a sin square x plus cos square x equals to 1, or 1 minus cos square x equals to sin square x. Then 1 minus cos square a equals to sin square a, 1 minus cos square b equals to sin square b, and 1 minus cos square c equals to sin square c, or sin square a into sin square b into sin square c equals to k square, or square root both the sides and we get k equals to plus minus sin a into sin b into sin c. Then we know the k from equation 1 and 2, k is the value of 1 plus cos a into 1 plus cos b and into 1 plus cos c. Also k is the value of 1 minus cos a into 1 minus cos b and into 1 minus cos c. Then 1 plus cos a into 1 plus cos b into 1 plus cos c equals to 1 minus cos a into 1 minus cos b into 1 minus cos c equals to plus minus sin a into sin b into sin c, hence proved.